Hey everyone, Jamie here from TechnicalCafe.com, and in this tutorial we're going to be talking about the stack data structure in Java and how we can go about using it within our programs, as well as what an example use case for it might be. So first and foremost, what exactly is the stack? So a stack is a type of data structure in which there is a last in, first out, oftentimes called LIFO, architecture. So basically the last thing you put into the stack is the first thing that has to come out of it. And a good way to explain this would be to imagine a stack of lunch trays in a cafeteria. If you keep adding them to the stack after you're done washing them or something like that, the first one that somebody's going to come along and pull off is going to be the last one that you put onto the top of it. And that's just basically how a stack works. So let's take a look at the code here. We have a class called stack practice, and within this class we have the main method. In order to implement the stack, what we're going to do is come over here and import the stack class. So we'll say import java.util.stack, and then we'll come down here and actually implement the stack within our class. So in order to do that, we're just going to instantiate a stack, and we'll say stack, we'll call it myStack equals new stack. And one of the first things you'll notice is that we get an error here in our compiler, and the first error is basically just that the myStack object hasn't been used yet in the program. But the one that's more concerning is that the stack class here is actually underlined. And the reason for that is because the stack class supports parameterization. So we could say, for example, integer within a set of triangle brackets, and we could say the same over here. And what that basically would do is allow the stack to have better type checking at compile time. So if you put an object into it that isn't an integer in this case, what would happen is the stack, you get a compiler and you wouldn't be able to continue any further. Right now, as it is, we're just going to leave that parameterization off, but just know that the stack will accept any object in this case, and in a production environment, you're probably going to want to include some type of parameterization or type checking. So anyway, now that we have our stack, let's come on down here and add a couple of things to it. In order to do that, we're just going to use the push method. So we'll say myStack.push, and we'll just put in the number 1. And we'll just continue on here a few more times. So myStack.push, we'll put in the integer 2, and we'll say myStack.push, and we'll add in the integer 3. So now that we have 3 integers in our stack here, let's go ahead and take a look at the first item on our stack. Given that the stack is a LIFO data structure, or last in, first out data structure, we can take a look at whatever's on the top of the stack, so the last thing that we put into it. And what we can do, the way that we can do that is by using the peek method. So if we were to print that out, so system.out.println myStack.peek, what we would notice is that it should print out the last thing we put on the stack, which is the number 3 here. So let's go ahead and compile and run this, and you'll notice that the number 3 printed out. Important thing to notice that when you use the peek method, it doesn't actually remove anything from the stack. So basically it's just as if you went over to your proverbial stack of lunch trays, looked at whatever tray was on the top, and then walked away. However, let's say we want to remove something from the stack. The way you can do that is by using what's called the pop method. So let's go ahead and print out something. So we'll say system.out.println, and we'll just print out whatever gets popped off the stack. So we'll say myStack.pop, and what should happen is the last thing that was put onto the stack should be the first thing that's removed from it. So let's take a look here. Let's go ahead and compile and run, and you'll notice that we have 3 popped off. That's the stack here. If we were to go ahead and pop off another item, we'll say system.out.println myStack.pop. We should have the next to last thing, so the integer 2, also popped off the stack. So we get 3 and 2. And just for fun, let's go ahead and say system.out.println myStack.peek. And then let's go ahead and underneath that say system.out.println myStack.pop. And what should happen here is that we should say C3, 2, 1, and then because we just looked at it the first time, when we do this last pop method here, we should see 1 again, and then our stack will be empty. So let's go ahead, compile, and run this. And you notice we see 3, 2, 1, and 1. Another quick method that we should talk about is the size method. So let's say we wanted to see what the size of the stack is. So we can say system.out.println myStack.size. And what this should do is print out the size of the stack. In this case, there's 3 integers in there, or 3 objects in there. And you'll notice that we get the value of 3. So now that we've learned a little bit about the stack, what are some uses for it, or what's a use of the stack? So one example of a use for a stack would be for implementing an undo feature in a program. So picture like Microsoft Word or Google Docs or something like that. As you're typing something in, maybe you type in a wrong letter, or you type in the wrong sentence or something like that. If you hit the undo button in Microsoft Word or whatever program you're using, it usually takes off the last thing, and you can just keep hitting undo, and it just keeps taking off errors or whatever that you might be undoing. And this is kind of like how a stack is implemented, and it may actually be implemented in some sort of stack where the last thing you typed in is the first thing that's removed. So that's just one example of how you might use a stack. There are plenty of other examples as well, but please feel free to post any questions that you might have in the comments, and thank you for watching.